BMAC, Lyryx Lab 6, question 1. We're being asked to find the start date, which is date 1. Date 2 is given April 4th, 2013. R is equal 3.25 or 0.0325. Principal is equal to $5,000 and I is equal to $60.99. Using the formula I is equal to PRT, we want to solve for T. T is going to be in years. So substituting for T, T is equal to I divided by bracket P times R is going to be equal to 60.99 I divided by bracket 5,000 times 0.0325, which gives us 60.99 divided by bracket 5,000 times 0.0325 bracket equal. So that's number of years, and then we want to multiply by 365 days, and that gives you number of days. That's 136.99 or 137 days. So now we're going to put the second function and days. We don't have a date 1, but we have a date 2. So date 2 is April 4th, so that's month is 4th, period 04, and year 2013, so last 2 digits, and we're going to enter that. So that's April 4, 2013, and then we scroll to number of days. DBT is 137, so we enter that, and then we scroll down to compute date 1. So we go to date 1 and compute, and our answer in here is November 18th, but we have to enter as 2012. So this is the answer that we want to have. So we want to November 18th. So now Lyryx expect answer in the following order. First year, so we type 2012, then dash November and OV and dash 18. So 2012 November 18. Question 2. Siran borrowed money from Stefan and agreed to pay back $500 today and $300 18 months from now. He has lots of money today and wants to pay back everything today, so we want to find equivalent value of $500 that he owes today. So that P1, $500 today is worth $500, so equivalent of $500 at times 0 is worth $500, but $300 18 months from now, that's the future sum, so we want to find equivalent value at times 0, so we're going to be looking for P sub 2, which is unknown, so that's a question mark. So we want to find equivalent value of $300 at times 0, and then we're going to add those two values, and that would be equivalent of $500 today and $300 18 months from now. So the only thing we need to do, we need to find that P sub 2. So in this case, P sub 2 is going to be equal to S sub 2 divided by bracket 1 plus R times t sub 2. So if we go to calculator, we'll have $300 divided by bracket 1 plus 0.0675 times 18 divided by 12 bracket equal so that gives us $272.42, and then we want to add 500 plus 500. So he would have to pay $772.42. 772.42 72.42 equal to discharge those two payments. Question 3, compute the maturity value. In other words, we're looking for future value. So we're looking for future value. What is given to us is present value of 1500. Term is 27.6 months, which is 27.5 years. Nominal rate J is equal to 6% or 0.06. Semi-annually compounded, that's M is equal to, future value is unknown. So we're calculating T is equal to 27.5, J is equal to 0.06, I is equal to J over M is 0.06 over 2, N is equal number of years and number of compounding periods, that's 55. And plugging into formula, future value is equal to present value times 1 plus I to the power of N. And now at this stage you have a choice. You can use your calculator, regular calculator or financial calculator. And let's take a look at financial calculator. So in this case we want to use 5 keys in here. So the very first thing, you want a second function and clear TVM. So first we want to have N is equal to 27.5 years. So 27.5, 27.5, that's your N. The next thing we have is present value, I, which is 6%, so put 6 and press I. Then we want to go second function and press I over Y. We have a lump sum, so it's only one payment, so please enter this, enter, and then scroll down, and C over Y is 2, so we want to put 2 and enter that, because there are 2 compounding periods per year, and cancel that. The next thing we want to go and place present value, that's $1,500, $1,500, but we want to change sign because we're investing $1,500, so put as a negative and press present value, then 0 for payment because we're not making any payments, and then future value we're calculating, so compute future value, and future value is $7,623.22. Now if we were to do a regular calculator, we can get the same answer. So we have 7623, 7623 and 22 cents. Now if we want to do a regular calculator, we'll have a 1500, 1500 times bracket, and then we'll have a 1 plus 0.06 divided by 2 bracket to the power, which is this one here, 55. Enter. And we have exactly the same answer. This type of question, question 5, you can use the formula f is equal 1 plus I to the power of m minus 1, where I is equal j over m, and solve for f in here, or convert this formula and solve for I, and then consequently solve for j. J is going to be equal to I times m. However, your calculator has built-in formula for that, so it's much easier to use calculator, and let's take a look how we're going to use that. So for the first example, we're going to use the calculator for this. So press second function and 2, and what we need to do, we need to scroll to find effective rate. So effective rate is given as 4.25, 4.25, 4.25, enter, and then number of compounding periods, it's semi-annually, that's 2, and enter, and then you want to scroll down nominal and compute, and answer for this one is 4.21. 4.21. For the next one, clear. For the next one, we're going to calculate effective rate. So I'm going to go again, second function, 2. Now we have nominal rate is 6.25, 6.25, enter, and then scroll down until you see C over Y quarterly, that means 4. So put 4, enter, and then scroll down until you see effective and press compute. It's 640. So the answer for this one is 6.40. And you do the same thing for the next three ones. Question 4. A financial obligation was to be settled in 2 payments. So we have a now, today, at time 0. The first payment was supposed to be taking place 2.5 years ago in the amount of $2,500. And the second payment 3.5 years from now in the amount of $2,000. The debtor missed the first payment of $2,500, and has proposed to settle the obligation with 3 payments. So let's take a look at so this is the original schedule. The original schedule called for $2,500 2.5 years ago and $2,000 3.5 years from now. The replacement schedule calls for first payment in the amount of $750 today, now, at time 0. Second payment 1.5 years from now in the amount of X. And last payment 3 years from now in the amount of 3X, 3 times as large as the second payment. So if we choose focal date 3 years from now, we want to find basically on the focal date equivalent values of all the original payments. So we want to find equivalent value of $2,500 on the focal date and $2,000 equivalent value on the focal date. Then we want to go to the replacement schedule and find equivalent value of $750 on the focal date and value of X on the focal date, and 3X is going to be right on the focal date, so we don't have to do anything. And then we're going to equate the equivalent values from the original schedule to the equivalent values of the replacement schedule and solve for X. So now we want to find future value of $2,500 on the focal date, which is 3 years from now. So that's going to be future value 1. And then we want to find present value of this future value 2 on the focal date. So that's present value 2. Then we go to replacement schedule, and we have a present value 3, which we call that first payment in the replacement schedule of $750. We want to know how much that money is going to grow from now until 3 years later. So we're looking for future value 3. Then we want to know how much the second payment of X is going to grow from 1.5 years from now until 3 years, which is period of 1.5 years. So that's future value 4. And then we want to know how much future value 5 is going to be, and there's no time period because it's exactly on the focal date. So we know right now that present value of 3x is equal future value of 3x because it's right in the same time. So we know already that's equal to 3x. So now we say that summation of future value 1 plus present value 2 from the original schedule has to be equal to future value 3 plus future value 4 and plus 3x. So now just a question of calculating future value 1, present value 2, future value 3, future value 4, and solving for x. So let's do that. Now we just have to complete calculations. So we want to calculate future value 1 by formula. Future value 1 is present value 1 times 1 plus I to the power n1. n1 is number of years, 2.5 years plus 3 is 5.5 years times 12 compounding periods per year. So that gives you 66. And that answer is 45,374. Present value 2, we have only half a year, so n is equal 6. So to the power of negative 6, that gives you 1895.79. You can use your financial keys for that, or regular formula. Then we do the same thing for the replacement schedule. Future value 3 is going to be equal to 750 times 1 plus j over m to the power of 3 years times 12 is 36. Future value 4, 1.5 years. That's 12 compounding periods per year, so n is equal to 36. So that gives you 1033.95. Future value 4 is 1.5 years, so that's 18 compounding periods. So that's x times 1.1075 divided by 12, so that's in terms of x. And future value 5 is exactly the same because there is no time in between, so it's equal to 3x. If we use this equation in here, it's a key equation. So we want to add future value 1 plus present value 2. That gives us 6399.53. Has to be equal to future value 3 plus future value 4 plus future value 5, and then we're solving for x. X is going to be equal to 1285.45. So now we're going to say that replacement schedule is going to be 750 plus 1285.45 a year and a half from now, and 3 times 1285, which is roughly $3,800 3 years from now. The last question, you want to find equivalent interest rate. You can use a formula that is given to you in formula sheet for ISAP2, or you can use your calculator. If you're using calculator, first you want to find effective interest rate for this given one. So you want to find effective rate and then find the nominal rate. So let's take a look for the first example. You want to find effective rate for the first one. So let's clear this one. So I want to have a second function and convert. So the nominal rate is 5.75. 5.75. 75, and that's nominal, so enter. Compounded monthly, so we'll go to compounded monthly, that's 12, enter, and you're looking for effective, compute, and then we want to find compounded semi-annually nominal. So you want to go and change compounding period to semi-annually, because that's what it says, semi-annually. So you go to semi-annually, press 2, enter, and then you look for nominal and compute. It's 5.82, so you're writing here 5.82. And if you want to go for this one, so for this one we'll go again and clear. So 6.50, so we'll go second function and convert. So nominal is 6.5, 6.5, press enter, and it's compounded monthly, so we want to go to compounding, compounded monthly, so that's 12, enter, and first find an effective rate, compute, so it will be 6.7, then we'll go to quarterly, so change this one to quarterly, which is 4, enter, and then look for nominal and compute 6.54. Otherwise you look for formula ISAP2 is equal to 1 plus ISAP1 to the power of M1 over M2 minus 1.